Okay, I've decided probably not to go back and get 28 only because it feels like maybe a lot of questions to do on a video. And then if you would like more on this, mind you, you have to watch them quickly and respond quickly because we're such a hyper speed course here. But if you'd like some more examples for me to make a video creating more examples, just let me know as soon as you possibly can and I'll add some. So for the moment, start with this one. So let me say a couple of things first about factoring. Okay, so when you see four pieces, four terms, the likely scenario, you can see this on the formula sheet too, the likely scenario is that you'll want to group them, the first two together and the second two together. So let me just first look at these first two pieces. First, when you're trying to factor something, you always get 0 on one side so that you can set the factors equal to 0. If you have anything different on the other side, then you don't know which portion each one would take up. So if you factor something on the left and it equals to 6, one of them's 3 and one of them's 2, or one of them's 1 and one of them's 6, and so forth. So you can't know for sure what's what. So always get 0 on one side. This already has 0 on one side, so we're just going to try to write it as a product. Once you have that, the very next step is factor out common terms. If you factor out common terms, you could do a tree for each one. Basically, for any factor, kind of whole piece factor, which is either a prime number or variable, in the end, what you can factor out is the lowest power of that that's present. So, for example, we have b's here. I have 2 here and 3 here. The lowest number then is 2, so I'm going to be able to factor out a b squared. But in the same way, between 80 and 32, I would factor this however I wanted to. Probably you would do 8 and 10. Maybe here you'd do 2 and 16. Once you've done a branch in a tree, cross out what's above it, because that's already here and you don't want to double count things. 8, maybe you'd say 2 and 4. 10, 2 and 5. Now these can't factor anymore. This can't. The 4 can. So I have 1, 2, 3, 4 2's and a 5. Over here now, the 16 could be factored 2 times 8. The 8 is 2 times 4. And then the 4 is 2 times 2. So I have 1, 2, 3, 4, 5 2's. So then over here on what I can factor out, I take the lowest power of 2, which is 2 to the 4. And I would take the lowest power of 5, but there's no 5 over here, so that's the lowest power, is 0 5's. So the thing to factor out is 16b squared. Now the other thing about factoring is that you can't just, multiply by things or divide by things. You can multiply by 1, divide by 1, or add or subtract 0, and you just choose convenient ways to do it. So because 16b squared is what I want out of there, what I'm really doing is multiplying by 1 in a 16b squared over 16b squared kind of way. And I leave the top one on the outside and move the bottom one on the inside. Then I'm just going to separate this fraction. $80 over 16 is 5. b cubed over b squared is b. 32 over 16 is 2. B squared over b squared is 1. So now that's factored out. So now I'm going to do this grouping. So 80b cubed, well, I guess I don't need to rewrite it. It's sitting right there. So out of the first two, I'm taking 16b squared. $80b cubed over 16b squared is 5b. 32b squared divided by 16b squared is 2. And if there's a minus here, you will always factor out the minus for sure. And then 45, there's only one b here and no b's here, so I can't factor any b's out. 45 has a 9, 18 has a 9. Most of the time, you'll just go ahead and factor things out. Use the tree if you're not sure. And let's say that you just factored out a 3. Then you would get 15b. Don't forget you're factoring out a minus, so you get negative 6. And then these two don't match. If those two don't match, then you can't group. But then you should check and make sure that you factored out the highest common term you could. So I'm going to factor out a 9. And I get 5b minus 2, and that equals 0. From here, this is the common term. So I factor out 5b minus 2. And if I divide all that by 5b minus 2, I'm left with the 16b squared. Factor it out of here, and I have minus 9. Because this power is 2, we're not finished. We have to get them all down to linear. If this was, there's sometimes when this still isn't factorable, but that's a 2, and then you get, well, it's factorable, but down to complex numbers, imaginary pieces. But even over just the reals, this isn't through because of that minus. So 5b minus 2 times. This is the difference of squares. This is one of the things on the formula sheet that you really need to kind of make sure you can recognize when you see it. 16 is a square and b squared is a square. A variable to a power is a square if the power is even. It's just half that many that's getting squared. So square root of 16, square root of b squared, squared minus 3 squared. So 5b minus 2. 4b minus 3, 4b plus 3. Once you have this, you just set each piece equal to 0. So we have 5b minus 2 is 0, or 4b minus 3 is 0, or 4b plus 3 is 0. Move over the 2, move over the 3, so I'm adding 2 to both sides, I'm adding 3 to both sides, subtracting 3 from both sides, because with just one side of an equation you can't add or subtract things that aren't 0 or multiply or divide by things that aren't 1. And once you have 0 on one side, you want to keep it. But now that we have this ready to solve, then we can move things over. So b equals 2 over 5. That's dividing by 5 on both sides. B equals 3 over 4. That's dividing by 4 on both sides. Here I also want to divide by 4 on both sides. Because none of these have a plus something times I, these are all real numbers. So it has 3 real solutions and 0 imaginary solutions. And then these are the solutions. It asks the question in 2 pieces, but in this case we kind of had to solve it first before we knew the answer to the first part. Okay, So the next one, I don't have 0 on one side, so I need to get 0 on one side. So I'm going to subtract what's on the right from the left. There's two ways that you might think about this. You might first say, I'm going to just multiply through by the common denominator, which is p squared. Or you might first think, I need to get a common denominator. You're going to end up with the same situation on both sides. We need to make a little note that p cannot be 0, because we're going to have the p's all out of the denominators, but they are currently in the denominator, so they can't be 0, or then it would be undefined. So make a note of that, and then if you get a solution of p equals 0, then you know to cross that one out and just take whatever's left. Okay, so if I just multiply through by p squared, then I get 7 times p squared plus 23 p squared over p is p, and then a minus 20. If instead I get a common denominator, then I would have 7 p squared over p squared plus 23p over p squared minus 20 over p squared is 0. So then 7p squared plus 23p minus 20 divided by p squared is 0, and then you'd multiply by p squared on both sides to get it out of the denominator, and you'd still have 0, and you'd end up back here. Okay? So we had 7p squared plus 23p minus 20 is 0. We need numbers that multiply together to give the product of these two. So multiply there and then add to make the middle one. So 7 times negative 20 is negative 140. So we have to come up with factors of negative 140. So 1, negative 140, or negative 1, 140. 2, negative 70, negative 2, 70. 4, negative 35, negative 4, 35. We're looking for them to add up to 23, so as soon as it adds up to 23, we can stop. 5, negative 28, negative 5, 28. Fortunately, because I'm out of space, that adds up to 23. So I put a technique on the formula sheet for you to kind of write this in a little square and then a diamond. Typically, though, when I do this, I do it by grouping. I say the 7p squared plus, and then I rewrite the 23p according to this. So 28p minus 5p. It doesn't actually matter what order you write those in. It'll still work out. Okay, so out of these two, I can factor a 7p. And I remember there's a negative. I always take out the negative, and I can take a 5 out of those. Because I took out the negative, this is a plus 4. And because these match, I can now factor them out. Set them each equal to 0. Subtract 4. Add 5. So p is either negative 4 or it's 5/7. Okay, so now we have this one. Now this is a little different, makes me look a bit like a liar. So this already has 0 on one side. It's not exactly a polynomial, so that's what makes it different. It's also not linear pieces. But this is to a point where we actually have to move that one over because we have these exponential fractions, fraction exponentials. So we need to move this over so that we can take these to powers to get rid of the radical. So typically, we're trying to isolate x, and so we have to get 0 on one side so we can factor. In this case, I really need to isolate these radicals so that we can get rid of them. So it's a different step in the process. It's sort of an order of operations type of situation. So because I have these radicals, I need to isolate the radicals. Normally, you only have one, and you just try to get it by itself. It's going to be okay. It'll work out. But the first thing to try to do is, pick one of these and try to isolate it. So I'm going to just pick the first one. So to isolate it, I'm going to move the other one over. Because of the minus, I add it to the other side. Now, because these roots are the same and it's odd, I really could just drop them and say then 6p plus 1 is 4p plus 8. But to properly kind of go through the process, this is 6p plus 1 to the 1/5 power. If there were a power here, that would be the numerator. The denominator is always the one in the radical. If there's nothing there, it's 2. So 4p plus 8 to the 1/5. Now, I want to get rid of this. So because a to the m to the n is a to the m times n, if I take this to the power of 5, it'll cancel that out. If this was 2/5, I'd do 5/2. It's always just the reciprocal. So 6p plus 1 to the 1/5 to the 5th equals, and I have to do the same thing on both sides. So I take it to the 5 on both sides, and then this is 1/5 times 5, so that's 1, so now 6p plus 1 equals 4p plus 8. Now we can go to isolating p like we normally would have. So we'll subtract 4p from either side, and then we'll subtract 1, divide by 2, p is 7/2. Okay, so now we have a word problem. Sorry, this one's a little harder to collect here. Okay, the percentage of the drug released into the bloodstream, T hours after being administered, is affected by numerous variables, including drug solubility and filler ingredients. So we're assuming this fictional drug and dosage, and the percentage of the drug released is given by this value over the first 30 hours. Okay, so from 0 to 30, this represents. And there you can see what the graph is. So we want to first determine the percentage of drug released after 14 hours. So this function gives you the percentage of the drug released. The percentage of the drug released, P. So all I have to do there is plug in 14. So P of 14 equals 44 times 14 to the 1/5. Now, I don't know the fifth root of 14. I kind of doubt you know the fifth root of 14. We want to round to the nearest whole percent, though. Okay, so I'm going to get my calculator. 44, whoops, that's too many, times 14 to the power of. If your calculator jumps up like that, then you can just put the 1 divided by 5. To get back out of it, you click the right arrow. If it doesn't do that, then you need a parentheses around the 1/5 to let it know that 1/5 is your power. So 75 is the percentage when we round. Okay, and the next question is, how many hours are required for 65% of the drug to be released? Round to the nearest tenth of an hour. I really wish I'd gotten smaller of this. Okay, so we want now for P to be 65. So we want to know when 65 has been released. So 44 t to the 1/5 equals 65. So we divide by 44. And then we have t to the 1/5 is 65 over 44. So to get that 1/5 away, we need to take it to the 5th power. So t to the 1/5 to the 5th is 65 over 44 to the 1/5. So 7 hours if we round. Oh, no, round to the nearest tenth is still 7.0. Okay. Ah, I did have that other question. It's right here. So this should be number 28. Okay. So what we're going to do, this is covered in this section if you read the e-text, is things like when you have something that's really a quadratic but in terms of something else. So like if we saw something that had p to the 1/5 and then p to the 2/5 and those were the only powers, then that's a quadratic where you make a substitution for p to the 1/5. And then p to the 2/5 is that thing squared. So in this case, if we just put this through b squared, we would get a b to the 4th, and would have b to the 4ths, and would have numbers, and would have b squareds, and that's it. So that means we want a substitution for b squared. Usually we use u for substitutions, so I guess I will. So u equals b squared. So then we have u times u minus 2 equals 3u minus 2. So u squared minus 2u. I'm trying to get 0 on one side at this stage. So distributing through, subtract 3u, add 2. And I don't have things which can multiply together to give 2 and add together to give -5. And I know that because the only way to get 2 is 1 times 2 or negative 1 times negative 2. So I'm going to do the quadratic. U equals negative negative 5 plus or minus square root negative 5 squared minus 4 times 1 times 2 all over 2 times 1. 25 minus 8, 17. Okay, so these weirdly are answers for b squared. So 5 minus root 7. These are both okay. Both of these are positive, so we'll have 4 solutions in the end. B can be the square root of 5 plus root 17 over 2, or it can be negative that square root. Let's see. Interesting. It makes me feel like I made an error, but maybe it wanted decimals, because otherwise this is very strange. Well, now I really wish that I hadn't accidentally closed that tab. Okay, so b could be square root of or negative that square root, or square root of 5 minus negative square root. So however it ended up it may want you to enter it exactly like this, but anyway, these are the solutions. That wasn't the easiest substitution question you'll ever see in your life, but you can do these practices and see how you do. Okay, last one on this section. This is rewriting a formula just to solve for one piece of it. So T1 is in the denominator. You could cross multiply. I think that's what most of you would do right away. You could also turn these upside down. So you could, if P1 V1 over T1 is P2 V2 over T2, then T1 over P1 V1 is T2 over P2 V2. So you could do it that way. You can also just cross multiply. So P1 V1 T2 is P2 V2 T1. Now I'm trying to solve for T1, so I would just divide. And that's done. So that's the answer for that. And that wraps up 1.6. Let me know if you have any questions.